Hey guys, I'm here for a bonus video. I'm so excited about Bridge that I had to make something for you today. I got a lot of new patrons in the last week or so. So I wanted to challenge myself to make a 5-minute video on Bridge math today. And I also wanted to introduce the person in my background. That's Jerry Lucas of the Ohio State University. He led that team to its only national championship in men's basketball in 1960. Also in 1961, posted the NCAA's only ever 30-point, 30-rebound game. So that's Jerry Lucas. That's in honor of the NCAA tournament and making your brackets, all that good stuff for your favorite teams that happens this week. So without further ado, let's go to the share screen. I'm already behind pace for making this in 5 minutes, but I'm going to keep on trying until I get it done. All right, share screen. So last week on Thursday, I did a presentation on Zoom before the Raleigh Bridge game, and it was how to upgrade and downgrade your hand. And the first principle is that you want honors with length. So I gave you the project of opening a spade with the 5-5-2-1 hand on the left and imagining that your partner had the 4 queens and flat shape. This was the very best distribution of 2 aces and 2 kings that we could give because they are concentrated in the long suits. And in fact, if both the major suits break 3-2 here, you're going to make a game. All right, compare it with when we start getting like really nasty, like putting the honor cards in the short suits. Do that and that and this. Now, like, think about trying to make a spade contract. You're going to lose a couple of spades. You're going to lose 3 hearts. The queen of diamonds does you no good. Like, you might not even make 2 spades on these 2 hands. So that was all to illustrate the point of you want your high cards in your long suits. That's a reason for upgrades. So here's the math. How would I come up with a number like on this original hand? How would I come up with a number like it's close to 50-50? That these 2 hands would produce a game? Well, the 2 things we need for this to make game are spades and hearts each breaking 3-2. Now, I've already memorized that when I'm missing 5 cards, the odds that they're going to break 3-2 is 2 out of 3, 66.7% basically. And one thing about odds, figuring odds, is if you need 2 things to happen, the likelihood that they'll both happen is the odds that the first thing happens times the odds that the second thing happened, given that the first thing happened. Mathematicians have a fancy name for that. It's called Bayes' theorem. It's the basis of conditional probability. Here, I need my spades to break and my hearts to break. What are the odds that the spades are going to break? 2 and 3. What are the odds that the hearts are going to break? Given that the spades break, 2 out of 3 is probably still close enough for horseshoes and hand grenades. How do I use these 2 out of 3 numbers? I take the likelihood of one, that's 2/3, times the likelihood of another, that's 2/3, and I come up with 4/9. That's pretty close to 50%. The other thing about odds that I want to impress on you today, and by the way, like, this is about the only bridge math you need. Let's say you're in a slam that requires 2 finesses, and we want to figure out requires one of 2 finesses. We want to figure out what the probability that that slam will make is. So if we want to figure out the probability of something happening, it's the same as asking, what's the probability of it not happening? So what's the probability that both your finesses are off? Well, the odds that the first finesse is off is 50%. The odds that the second finesse is off is basically 50%, and it doesn't depend on whether the first one's off or not. 50% times 50% is 25% that both finesses are off. You take the complement, which is 75%, and that's the odds that at least one of them will be working. Hope you enjoyed this quick tutorial on bridge math. Honestly, this is about 80% of the bridge math you need. Talk to you guys soon.